Tangent. Yeah, tangent. So,
do we do the same process?
I'm going to start this, though, the exact same way. If we're wanting that algebraic simplification, this is 3x squared plus 4 equals 7, right? Easy to solve. Harold, what's the first thing I'll do? Minus 4. You can keep writing it. You can also start lifting some of those steps. I do the minus 4 in my head and just write equals 3. Leslie, next step. Beautiful. You can actually write the division by 3, or you can do that division in your head. X squared equals 1. Emily, last step.
Square root.
Square root. I will be really mad at you if you type the square root of 1 in your calculator. You giggle. My calculator students do that all the time, and then I see it. Square root of 1 is 1. 1's the nicest number because you can do anything to it and you still just get a 1. But why is what I've written here incorrect? Positive or negative, right? Why anytime I physically square root something on my paper, I have to include the plus and the minus. So if I translate this mathematics to our specific scenario, it looks like I'm getting to a place where I have tangent of x equals plus or minus 1. We're okay now, getting a little more comfortable with how to get started on these? Now, Daisy, yes?
So you remember how the last time that we were working problems like this, we had to find out if it was positive or negative, the answer, like you have to choose one or the other. Here, you don't have to do that, right?
Correct. Here we do not have to do that. There's no caveat at the beginning that states your cosine is a negative value, because that would impact everything we did. These have a little bit of different mindset than the ones we did at the front of the unit. Great clarifying question. Now you guys said tangent was going to be a little bit more rigorous, and I 100% agree. With sine and cosine, our processing was a little bit nicer, because if the problem came as a sine, we remembered from last semester that sine was immediately impacted by a y. Cosine problems were immediately impacted by an x. Tangent, though. Who was that? That was correct. Who was that? Natalie, what's tangent? Y over x. So in this scenario, I'm going to have to use the quotient of these two values to try and find the right answer. If I come to my sine over here, I'm always going to begin by looking at these 3 possibilities, and then I'll build my other answers from here. There is one place on this particular sign, a sign on the wall, where I could take the sine value, divide it by the cosine value, and get a 1. Spelling words out there. How do you know? They're the same. And if ever I take 2 identical things and divide them by each other, I get 1. Everything's the same. Now the tricky thing here, the other tricky thing, I found my first answer is at pi over 4. Plus 2 pi k, if you want to be writing that down. How many other answers am I going to have? Alan says 3. If I just had positive things, I would have 2 answers. If I just had negative things, I would have 2 answers. Here I want both, so I need 4 total answers. Which means basically I'm going to be in every single quadrant. And remember, if my initial angle was over 4, all of my angles are over 4. And pi over 4s are my favorite. I was always really easy. These ones were really easy for me to remember because of the pattern. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. It's just the odd numbers on the over 4 angles around your circle. 2 pi k, 2 pi k. 2. What do you think? Tangent is a little more rigorous. It's a combo of the 2. What? Go back to 27. Let's do another tangent. All right, model problem number 2 on the bottom of 27. I'm going to ask that you guys get started on this, and then we'll talk about how to finish at the end in about 1 minute. I'm just going to give you 1 minute to get tangent isolated, work independently, and we'll meet up again in a minute. Good, Saida's already there. Everybody else keep going. Was it doing anything weird?
No, it's good.
You had a different answer.
Yeah, because you know how it was like 1? I thought it would be like...
Gotcha. So, good clarifying question. We're going to do it in a second where we do consider those. But if I took this and took the y and divided by the x, 1 over 0 would be undefined. Had it been 1, 1, and I divide those, yes, I would say this would be a potential answer. But if these are our answers, our equation will be showing up as it's over 0 or undefined. So we'll look at one like that. So feel free to ask that question.
It's because you looked at me like that. Was
I did? Because you were looking at me weird. I thought something was on my face or something.
All right, Saida, what do you have? Tangent of x equals what? Square root of 3. Can we get on board with that? She moved one of the tangents over there, moved the square root of 3 over, and got to a place where tangent equals square root of 3. So this is interesting. And I need to clarify this because first period was a little bit confused. I had some students saying, you mean plus or minus square root of 3? And I said, no. This square root came to me in this format. I did not physically square root anything on the paper to cancel a square. Only include the plus or minus if you yourself are canceling a square by using a square root function. This is just a number that was on in the problem already. So what I need right now is a y over x that is equal to a square root of 3, because tangent includes the ratio of y's and x's. When I think about my possibilities, I'm immediately eliminating the 45-degree angle from this one, because I saw that at 45, the ratio is 1. And my ratio has a square root of 3 in it, so I know it's going to be one of these guys where the square root of 3 is showing. So the major processing I need to complete is if it's going to be the 30 or the 60. At 30 degrees, if I took the y and divided by the x, this is my 30-degree processing. I would have 1/2 divided by square root of 3 over 2. At 60 degrees, my y over x would be opposite, square root of 3 over 2 over 1/2. This involves more complicated like fraction processing. I have to keep it, change it, and flip it in these scenarios. If I do this one, that's square root of 3 over 2 times 2 over 1. What can I do through multiplication? What's legal? Cancel. The square root of 3 over 1 is square root of 3. This is my answer. If I did this one first, I would have gotten to a place where I had 1/2 times 2 over the square root of 3. I'd cancel, but I would be upside down from what I need in this problem. So I know 60 degrees is one of my answers. In radians, that's pi over 3. I know I'm going to need another answer because they generally come in pairs when I'm dealing with these problems. Where else is tangent positive? The third one. The over 3 angle in quadrant 3. Let's think about that. Over 3 is 60 degrees. So I want the 60-degree angle in quadrant 3. This is helpful for you when you don't have your unit circle anymore. Half a circle is 180, right? I went 60 more. That means I'm at 240. I just take 240 and divide by what I started with, 60. 240 by 60 is
4 pi over 3.
4. So my answer is 4 pi over 3. That trick works everywhere on the circle. And then, of course, I'll add 2 pi k, 2 pi k. How are you feeling? Okay. I have 8 minutes, and I want to preview something else that's coming up the pipeline really soon. You have 6 homework problems, though. They're nice like these. I think you'll be fine. But go to 29 real quick. And look at that student practice. Oh, no, I'm sorry. The do first here at the beginning. first one. So this is just getting us some insight into what's coming. These ones won't show up on your homework assignment. Homework assignment's nice, like the ones we just worked on together. But the goal is that we get to some problems that are a little bit more rigorous. There's like an intro calculator thing here, which we would do if we had time, but look at the second box. This says try solving 2 cosine of x sine of x equals 2 sine of x on the interval negative and each number. So we started with nice ones that had sines and cosines involved. Then we went to that more rigorous scenario of tangent. And why is this even more rigorous here, based on what we're seeing?
Because there's both sides.
Both mixed in one equation. And so far, all the examples we've been doing have been focusing on one function in isolation, never a combo. So let's talk algebra, right? It was helpful to do algebra first on the last examples. If I had to break this down into a similar algebraic scenario, I would relate this to something maybe like 2xy equals 2y. More than one variable, right? And if this might not have been in Algebra 1, maybe in Algebra 2, if someone had asked you to do this, to solve this. Back then, you were trained really well in this scenario, and you knew right away, can't solve something like this unless it equals 2, 0. So you would move the 2y over. 2xy minus 2y equals 0. And now I'm in a better place. Then you'd look at this with a thoughtful eye, and you would notice something about these two terms. Anybody think they noticed something nice about these two terms?
The 2y.
2y shows up in both. So when I notice that commonality, I do this cool thing, you should try it sometime, it's called factoring. I take that common factor out of both terms. Claudia, what's left in the first term if I get rid of the 2y? An x. Minus, Brenda, what's left right here if I get rid of the 2y? Trick question. Looks like nothing's left, right? What number would I put there? A 1. When in doubt, ask yourself, 2y times what thing would get me back where I started? And it's a 1. Do you guys remember how we would solve now? You're overthinking. So this becomes so nice. 2y equals 0 and x minus 1 equals 0. And I break it apart into 2 smaller equations. Over here, I could isolate y by dividing by 2. And y would equal 0. Over here, I'd isolate x by adding 1. And x would equal 1. This is how algebra problems like this are set up and how you've been doing them since you were in algebra. We need to try to apply this strategy to our problem right here. It's identical, but it's unfamiliar because the trig shows up. First thing I'm noticing, if I have more than one trig function in my problem, I've got to get the equation equal to 0 before I can start. So I'll move the 2 sine of x over to the other side. Be very careful because I've seen this year after year after year. Students write this on their paper, which I get, and they get the 0 over here. But do you know what they do over here? And it drives me bananas. Those are not like terms, so I just have to write them right next to each other. And now I look with a thoughtful eye, and I hopefully recognize what Jaime recognized for us over here. That they both had a 2y. Here they both have a 2 sine. Take it out. And I'm left with, in the first term, the cosine. This is like when I asked Brenda, what's left on the second term? And she's like, I don't know, nothing. I put a 1. I break this apart now into 2 equations. 2 sine of x equals 0 and cosine of x minus 1 equals 0. These are not nearly as scary to solve. I just divide on this one and add over here. Looks like sine of x is 0 and cosine of x is 1. Perfect timing. finish this, I'm looking for where sine is 0, or where I have a y of 0, and where I have an x, a cosine of 1. If you've been focusing your attention just on this bottom sign, you're going to think that there are no answers. But look right above. There are some angles we have been neglecting so far that are very important. 0, 90, 180, 270. At those values, I can find places where the y value is 0. There are 2 places. Over here at my start, and over here at my halfway. I can also find a place where cosine is 1, or where my x is 1. Right here at my start. Not at the halfway, because that's an x of -1. And that's not what I'm asking for. So my answers to this first baby equation would be 0 plus 2 pi k and pi plus 2 pi k. I could also write 2 pi plus 2 pi k, but 0 and 2 pi are the same thing, so I don't need to list them twice. Cosine is 1, that's the x, at 0 again, or at 2 pi again. I do not have to list those all more than once. I could have stopped over here because the answers repeat themselves. I wanted to preview this with you today so that you could start thinking about factoring and how that's going to impact us. We will talk more tomorrow. You have 6 problems for homework. Good luck.